In Tennessee, a mighty Mississippi crossing in danger of imminent collapse.
Once you fall into this river, your chances of survival are minuscule.
In Australia, huge demolition turns to disaster.
It went bang, started to collapse, and then nothing.
The catastrophic destruction of a federal building in Florida ends in tragedy.
It just all collapsed.
Oh my God, there's people in there. Just how bad is this?
And in New Jersey, a devastating failure on a crucial highway project.
It was just unbelievable.
We saw the collapse. We saw the highway and the whole structure just fall.
With big bills, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. In big engineering, regular maintenance is just as important as cutting-edge innovation. Because sometimes when disaster strikes, danger has been hiding in plain sight all along. Like this catastrophe in Tennessee, a vital crossing with a potentially life-threatening weakness.
I could have been on that bridge. My family could have been on that bridge.
A busy Mississippi bridge with a perilous crack.
We need to get people off the bridge as soon as possible in both directions.
And a race against time to keep commuters safe.
We're like, what the heck's going on? It was not good. Extremely not good.
It affected Memphis. It affected the whole country.
Memphis, Tennessee. The mighty Mississippi runs through its heart, but it got its soul from rock and roll.
Some of the greatest music of all time has been recorded in Memphis. Everybody who was anybody, from Johnny Cash to B.B. King to Elvis. I mean, this is the home of Graceland.
Barry Moore was born and raised in Memphis.
What really put Memphis on the map is the music. All this stuff was taking place when I was growing up. It just made for a fantastic time. That's what makes Memphis special.
Music is still a big moneymaker for Memphis. The area attracts around 11 million tourists a year, generating more than $3 billion for the local economy.
For many travelers coming to honor the Memphis musical legacy, their first taste of the historic home of the blues is this. The distinctive M-shaped Hernando de Soto Bridge, also known as the I-40 Mississippi crossing.
The I-40 is one of the nation's most important interstates, stretching more than 4,000 kilometers from California to North Carolina. More of it passes through Tennessee than any other state.
Not only is the I-40 one of the busiest cross-country trucking routes, but the Mississippi River is one of the busiest commercial waterways in the world.
This busy waterway is subject to major floods, which ruled out building a suspension bridge. Instead, engineers opted for a tied arch design.
A tied arch bridge is like an archer's bow on its side. The ends of the curved arch are held together under tension by a horizontal beam acting like a bowstring.
Ted Kanazowicz is Director of Structures at the Tennessee Department of Transportation.
This is the tied arch structure, and the arch shape is held together by this tension tie beam. So the truss arch carries all the load of the bridge. And this tie girder doesn't carry the deck load, it only tries to hold the shape of the arch.
But with 60,000 vehicles crossing every day, the bow and string have to work in perfect harmony. Adel Abdelnabi is an associate professor of engineering.
You see that truck driving on top of the bridge? The weight of that truck will transfer using these cables up to the arch truss above. And at the same time, the truss will try to open because you're pulling them down. The only thing that's preventing them from opening is that tie girder. You can see it below the bridge deck. That's how this system works.
Construction was completed in 1973, and residents like Barry were so excited to try out their new crossing, they didn't want to wait for the official opening.
My family, before an interstate roadway would open, we'd get our bicycles, load them up, and then we'd go ride the interstate for a while.
For 5 decades, this epic bridge safely carried I-40 over the mighty Mississippi, an iconic gateway to Memphis.
One of the greatest things about this bridge, coming back home from a long trip, when you come across this bridge, you know you're back home. Seeing the city here kind of makes you want to pull off and check it out.
But in 2021, officials discovered the Hernando de Soto was on the brink of catastrophe. May the 11th, engineers were inspecting the I-40 Mississippi crossing. Shortly before 2 p.m., they noticed that something was very wrong.
Engineers called 911 to get this bridge shut down. Fast.
Memphis 911 emergency. Do you need police, fire, or ambulance?
I am doing a bridge inspection here on the I-40 Mississippi River Bridge. We just found a super critical finding, and one of the members that is split.
One of the crucial steel tie girders was almost severed by a massive crack.
We have a broken bridge member. We need to get people off the bridge immediately in both directions.
Vivi Merrick was on the bridge when traffic ground to a halt.
We're like, what the heck is going on? I think it was a firefighter that essentially stopped traffic by himself because he was like, oh crap, like this is terrible. We need to stop traffic right now. So it was like an emergency situation.
Now stuck on the bridge, Vivi knew things were serious.
We realized that it was not just a normal traffic jam. Oh my gosh, that's where we're kind of panicking. What are we gonna do?
This particular bridge carries 60,000 vehicles a day, but not only was it the closure of the bridge to traffic, it was the closure of the river to river traffic.
If this bridge collapsed, it could have been a huge disaster, not just for Memphis, but the entire country.
While it took around 2 hours to clear the bridge, thankfully for the time being, the almost 50-year-old crossing held firm.
I've been going over this bridge my whole life. I could have been driving across it the day later and it would have collapsed. So I'm glad that it was caught when it was. It was not good.
With the Hernando de Soto shut down, traffic was forced to detour through the city and over what's known as the Older Bridge.
The traffic tie-ups in the city of Memphis was just horrendous. Bumper to bumper, stop and go. It was a bottleneck everywhere.
Reverberations were felt across the entire country.
If you look at the map of the US, this represents the heart of the country. So having it shut down is like having a heart attack, and we saw that. It affected Memphis, affected the whole country.
A team of engineers was immediately sent out to assess the critical health of the structure, and within 3 days it was deemed safe enough for river traffic to pass below.
So the first thing that we did as a department was to declare that this was an emergency within the state because of the major corridor that it was. In the 3 days that the river was closed, more than 1,000 barges had already backed up on the river. So we knew that time was of the essence to get this resolved.
Allowing heavy lorries and other vehicles to drive over the top was a different matter. As a temporary fix, steel plates were secured around the crack. But while the team continued to investigate, the bridge remained closed.
This is the main navigation span for the river, and the fracture was found about 80 foot from this pier on the northern side of the bridge. The fracture occurred in one of the plates on the side, one of the plates on the top, and part of the plate on the bottom. So more than half of the section had been compromised.
The crack was in a critical girder which held one of the arches tightly in place. If the girder failed, just like a bowstring, it could release the tension, and the whole bridge would come crashing down into the mighty Mississippi below.
If we were building a bridge like this today, we would not use this type of structure because it's considered fracture critical.
If that beam had completely cracked, the entire bridge could have collapsed. It was just lucky the engineers found it in time.
The bridge inspector's swift action likely saved lives. With the weakness now identified, it was time for Memphis officials to devise a solution. But a crack this large doesn't appear overnight. Drone footage from an inspection 2 years earlier showed that the crack was already there. Despite its size at this stage, somehow it was overlooked.
I'm like, well, could it have collapsed a week ago when I was going over the bridge? So it freaked me out.
For local Barry Moore, the disaster triggered a memory of a kayaking trip under the bridge in 2016.
It's such a magnificent structure, I decided I'm gonna take some photographs from the underside. When the news of the crack came out, I went to my computer, opened up the pictures, and then I started zooming in. And lo and behold, there was the crack. Wow, 5 years before they found the crack, and I've got a picture of it right here.
Officials needed to determine exactly how long the structure had been compromised and what caused the fracture in the first place. A section of the girder was analysed, and the results were shocking. It seems the crack wasn't 5 years old, but more than 50. And it started in a weld.
The forensic report that we got from the materials science people suggested that the fracture was located within the weld and probably dates back to when the bridge was originally constructed in the late 1960s.
The problem was not with the steel itself, but a byproduct of the welding process: hydrogen.
The fracture was caused by hydrogen embrittlement that was located within the weld. As welds cool, they give off hydrogen. It's just part of the process of the melting of the steel. So if the welds are not cooled properly, then hydrogen can get trapped within the weld and can lead to just a very small fracture.
This bridge seemingly had a flaw in it from the get-go.
If left unchecked, a small fracture can develop into a huge problem. And with over 20 million vehicles a year testing these welds, the flaw was bound to grow bigger and more dangerous by the day. Ultimately, if it hadn't been caught, it could have brought down the entire crossing.
I could have been on that bridge. My family could have been on that bridge. Once you fall into this river, your chances of survival are minuscule.
While the road remained closed, Ted Kanazowicz was tasked with the massive job of getting one of the country's most vital trucking routes up and running.
The solution that was chosen was to add capacity. For about 180 feet on the structure, we were able to get 50,000 pounds of steel plates located, fabricated, and installed. And we put plates on this outside where the fracture was, and we put plates on the inside that wasn't fractured. Just in case something were to happen, we wanted to have enough capacity on the structure to carry the load.
The bridge was fixed and fully reopened to traffic less than 3 months after the emergency closure on August 2nd, 2021.
There was a feeling of relief to have the bridge open, knowing that we had done a good job in fixing it.
The new welds were made stronger and cooled longer than the original construction. A federal mandate now requires that inspections are also carried out every 12 months on all fracture-critical bridges.
This was a lucky escape, and a powerful reminder that with aging infrastructure, thorough inspections really are the key to avoiding potential catastrophe.
In big engineering, careful planning is the key to success. But sometimes even the best laid plans can go disastrously wrong. Like this catastrophe in Australia, where a routine detonation failed to deliver.
It went bang, started to collapse, and then nothing.
A demolition down under that went viral around the world.
It was so darn well built. It was quite funny when it didn't fall down.
A building determined to stand strong.
Safe to say, this demolition didn't go according to plan.
Brisbane is Australia's third largest city and the state capital of Queensland. Joel Dry is a local TV news reporter.
Brisbane has a really vibrant culture, and it's also the climate that makes this a really amazing place to live and visit. To the north and south, you have the Sunshine Coast and the Gold Coast. Beautiful, world-class beaches, the crystal clear waters, the wildlife. It's an amazing and vibrant place to live and work.
Brisbane owes its success not just to the beaches, but to some of the world's most fertile farmland, just west of the city.
As well as the climate, it is also the soil that makes this part of Australia so special. And that was recognised shortly after the city was founded. Farmers moved in, started growing crops. That continues to this day. It is now known as the food bowl of Australia.
Farmers took advantage of the rich economic opportunities that came with the fertile land. This small town, Redbank, found its niche in a specific crop: malt.
Malt is the unsung hero of one of Australia's most popular industries, and some might say favourite pastimes, beer.
Beer is a really popular drink in this part of the country, and the brewing culture has always been really strong in Brisbane ever since the city was founded.
From the 1960s, Redbank's malt was stored in this 4,000-ton bank of concrete silos.
The structure might look like a simple piece of engineering, but like all silos, it had to withstand the pressure of thousands of tons of crops or other materials pushing against the walls from the inside.
Redbank became an integral supplier for Brisbane's biggest brewer, producing one of the country's most famous beers. Paul Tully was a member of the local government at the time.
The silo was an integral part of Redbank, and it was a prominent part of the Redbank community. It was a major employer in our local district.
By 2013, the industry had moved elsewhere and the silo stood unused and empty. The land was to be sold for a warehouse development, and the structure was slated for demolition. For silo worker Brian Verrill, it was the end of an era.
Worked there for about 20 years. I was employed to keep the plant running and producing malt. The workers there, we were pretty much like a family. It was like, that was it, no more work there.
But this building was not going down without a fight. Sunday, May the 12th, 2013. Demolition Day. Reporter Joel Dry was in Redbank to capture the event.
I was sent down here really just to cover what was going to be a spectacular shot, an amazing picture of a big silo going bang and then falling over.
Almost 100 kilos of explosives were primed and ready to go.
They let off a couple of siren noises to prepare everyone.
There was a bit of a countdown and then the big bang.
She came down a couple of feet and then started leaning.
It went bang, started to collapse, and then nothing.
Built to withstand huge internal forces, it seemed this silo wasn't going anywhere.
It didn't break. Some were excited, some were in awe, and some were laughing.
It paused, it got stuck, and the big question for a lot of people was, is that it? Is that what's supposed to happen?
The silo that had stood tall for 50 years was still standing, but just barely.
The whole thing was meant to crash down in seconds. Instead, this 4,000-ton building was left looking more like the Leaning Tower of Red Bank.
After a few minutes, it became clear that something had clearly gone wrong.
But how had a supposedly routine demolition failed so spectacularly?
Every rumour in the book was raised by the locals.
The plan was to bring down a silo like a tree by blasting a wedge in one side. The challenge was using just the right amount of explosives.
Alex Romenikov is a professor of structural engineering.
So here we have a model of the Red Bank silo. So what happened during demolition? The bottom part where the explosives were placed was removed by explosives. The building started moving and stopped. And the critical question is how much explosives is required to make sure that the building will tip over in this direction and completely collapse.
Too many explosives would risk hurling debris around the site, but use too little and the building wouldn't come down.
The explosives are the triggers. They do not bring the structure down. It's the gravity that brings the structure down.
There was a lot of speculation about exactly what went wrong. Most people tended to think that they hadn't used enough explosive.
So, what actually went wrong?
This structure was incredibly strong, reinforced with steel to cope with the massive forces from the stored grain, pushing both down from above and on the walls from inside.
Here, it looks like they may have underestimated just how robust this building was.
Another possible factor is the precise way the silo was built. Having witnessed its strength after working at the silo for more than 20 years, Brian Verrill explains the process, known as slip form.
Silos were made in one piece, where the whole thing went up in the air as they poured until the desired height, and the walls were about a foot thick.
In slip-form construction, the structure isn't built in sections. Instead, concrete is poured into a vertical mould, with the liquid rising slowly enough for the growing walls to support the weight above. Once fully cured, the continuous concrete structure is incredibly strong and has no joints to create weak points.
Which is why it took an awful lot to blow it up.
With the blast in the past and the silo still standing, it was time for Plan B.
Then we started to see some heavy machinery roll onto site, some excavators. We then started to get a sense of what they're going to try to do is try to push it down manually. They kept knocking out brick after brick.
40 minutes later, after the bulldozers had come in, it finally hit the ground.
Despite strong resistance, the silo was finally defeated. Gone to make way for a new warehouse development. Engineers remain tight-lipped, so we may never know for sure why the initial demolition went awry. But one thing is certain, this silo was built to last.
People and buildings are built tough in this part of Australia. When we get knocked down, we get up again. This silo, it's not going to get back up again, but geez, it was hard to knock down.
In big construction, every element has to work together in perfect harmony. Get that balance wrong and the results can be catastrophic. Like this federal building in Florida that was hiding a deadly secret.
It just all collapsed. What happened and what made this building fall apart?
A disaster that rained down wreckage on the people below.
You're looking at this building with a caved-in roof and vehicles piled on top. Oh my God, there's people in there. Just how bad is this?
And a tragedy that inspired a young engineer to bring about a dramatic change in regulations.
We don't want to put a price on human life.
What can we do to prevent this from happening again?
Miami, on the southern edge of Florida, is America's gateway to the Caribbean and Latin America. But while this sun-drenched city has a lot to write home about, it also has a darker story to tell. Francisco Alvarado is a local investigative reporter.
If I had to describe Miami in 3 words, I'd call it a grimy, glamorous paradise. And the reason I say that is because it's a place that's full of beautiful people, beautiful buildings, but at the same time, there's a lot of people trying to come up and get away with things that they shouldn't be getting away with.
In the 1970s, Miami became a gateway for drugs being smuggled into the country.
There was this underbelly where, the drug trade started to blossom, and you had cartels starting to make inroads into Miami to start distributing cocaine.
In the 1970s, Miami became a gateway for drugs entering into the country, and it gained a reputation that was immortalized in popular culture with dramas like Scarface and Miami Vice.
It was time for law enforcement to take action. Now a construction site, in 1971 this plot was home to around 150 drug enforcement agents and staff, chasing down some of the biggest drug lords in the world. After graduating from high school, then 18 years old, Kevin Kramer inadvertently found himself with a summer job, fighting the war on drugs.
So when I first showed up for the job, I didn't realize it was for the DEA. Little did I know, though, that it was going to be in the forensic lab where they actually tested drugs that had been confiscated. It was not your run-of-the-mill kind of a thing that an 18-year-old would be doing.
Originally built in 1925, this 3-story building had a history that made it perfect for the DEA's purposes.
Back in the day, the building was actually a car dealership, so it had a unique feature where you could park cars on the roof.
So once the DEA set up the operations, there was no shortage of drug lords to go after. And they basically, when they would, get these guys, they would take their exotic cars and park them on top of the roof of the new DEA headquarters.
But the DEA's war on drugs was about to be dealt a major blow by a catastrophe that no one saw coming. Monday morning, August the 5th, 1974. DEA headquarters in downtown Miami. 18-year-old Kevin Kramer was on the job.
So the lab where I worked was on the east side of the building. The agents were on the west side of the building. And it was just like any other day.
But this was about to become a morning that Kevin would remember for the rest of his life. At 10:24 a.m., the rooftop parking lot directly above DEA agents and support staff collapsed.
This failure was so sudden. There was no warning. The roof just dropped.
And all of a sudden, there was just this whoosh. The lights flickered. It went dark for a little bit, and then the lights came back on, and we were all trying to figure out what the heck had happened.
Kevin and his colleagues were unaware that the west end of the building was now a pile of rubble.
Somebody said, "Clear the building." So we all raced out, and it was like something you'd never seen before.
Just minutes ago, 57 confiscated cars had been parked on the roof. Now they lay scattered among tons of concrete and debris, where moments before an office full of workers was having a normal day.
You're looking at this building with a caved-in roof and vehicles piled on top. All that comes to mind is like, oh my God, there's people in there. Just how bad is this?
First responders rushed to the scene as news of the disaster spread. And families across the city were left to wonder if their loved ones had made it out of the collapse alive.
The first thing that kind of crossed my mind after witnessing this was I had to let my parents know that I was okay. Later on, my mom has always told me that my dad, he was just quiet that whole morning.
As rescue workers frantically searched through the devastation, Reporters like Francisco Alvarado knew early on that the disaster was serious.
At the time, it was the biggest news story in Miami. Half of the building came down. It just all collapsed. I mean, it was one of the most horrific tragedies to happen in Miami.
16 people were injured in the tragedy, and sadly, 7 more lost their lives.
There was one story that really stood out of an agent. He was a Vietnam veteran, and it was like his first day on the job. And you start to think about things like that, and you realize just how lucky you were.
Half the building was lying crushed under tons of rubble and cars. Engineer John Pistorino, an expert in the field, was called to the site just hours after the disaster.
We were there right after the collapse. We were asked to go over there and investigate and find out what happened and why did it happen.
At first sight, some believed the culprit was the weight of the 57 cars parked on the roof.
As they accumulated more cars, that just created more load on top of the roof, which was one of the contributing factors to the building collapsing.
While there's little doubt what triggered the collapse, a parking lot is designed to hold cars, whether it's on the ground or up on the roof, so there had to be another reason why this one failed.
In an office used by undercover agents, John Pistorino quickly discovered that the building was hiding its own secret. While initial suspicions had focused on the weight of cars parked on the roof, John uncovered evidence pointing to a different reason.
But when I started to look at what the issues were, I immediately recognized that it wasn't because it was overloaded or anything of that nature. I found corrosions and cracking concrete that had been hidden behind cosmetic paint.
The cause was tragically simple: massive corrosion to the building's infrastructure that was hidden behind a recent paint job. It turned out an engineer had certified the building 6 years earlier, without conducting what's known as a destructive investigation.
A destructive investigation is exactly what it sounds like. You have to damage part of the structure so you can really see what condition it's in. For example, chipping away at the surface paint to uncover what's lurking behind.
Removing the curtain, so to speak, to see what's behind it.
But the source of the corrosion remained a mystery.
This building was over 40 years old, and Miami's humid and salty ocean air had long been corroding the reinforcing steel. But it turns out that inside this particular building, there was another ticking time bomb from the get-go.
While examining nearly 6 tons of rubble, John Pistorino and the team discovered that the source of the destructive salt wasn't the local sea air alone. Rather, the salt was in the building's structure from the beginning, a result of sand composing 1/3 of the concrete mix.
Here, the specific sand was laden with salt, and they were using salt-contaminated water to make the mixture.
You have to recognize that we're here on the coast of Florida, so there's a lot of salt already present in the materials that make up the concrete. When we build buildings, we have to wash the rocks and the concrete and make sure we get the salt out of it down to a very low level so that we don't have salt in the concrete attacking the steel.
In the case of this building, it appears that the thorough desalination process wasn't done.
Salt was actually embedded in the original construction, so it had a high content of salt, which attacked the steel. So as the steel got bigger and bigger, it simply cracked the concrete.
This structure was in trouble from the beginning. The concrete that relied on steel for strength was salty, which in turn started to destroy the steel inside.
The salt within the concrete was slowly eating away at the steel, and thorough inspections weren't done to catch the problem before it was too late.
The building had already gone through all these inspections, so the staff that was working there really had no reason to believe that they were in any danger or that something might happen.
With the war on drugs ongoing, the DEA moved their vital operations to another part of the city. But drastic action was needed to prevent construction oversights from happening again. And John Pistorino played a key role in devising new regulations.
In the wake of the disaster, a countrywide program was implemented that required buildings over 3 stories tall to be thoroughly inspected and recertified every 40 years.
We look for telltale cracks. Then normally we will even take a chipping hammer and remove the concrete that's already failed to see how the condition of the steel behind it.
It was an old building, but it looked fine. But when you start to think back to this incident, you realize just how fortunate you were.
We don't want to put a price on human life, so we do what is necessary and look at a building and evaluate it as though we lived there ourselves.
An engineer's work is never done, providing bigger and better resources for a growing population. And the bigger the project, the bigger the problems. Like this calamity in New Jersey that took down a brand new roadway.
This failure jacked up one of New Jersey's busiest intersections.
A catastrophic failure during the middle of construction.
When I first saw the wall bulging out and the ground lifting up, it was just unbelievable.
This disaster left residents reeling.
We saw the collapse. We saw the highway and the whole structure just fall.
The United States relies on a vast network of roads to support its bustling commerce, tourism, and interstate travel. And for the East Coast, one crucial piece of pavement is this intersection on the New Jersey Turnpike near the small town of Belmar. Mark Matthews is a local writer.
You know, coming from Philadelphia, heading anywhere, whether you're heading down to the Jersey Shore, whether you want to head to Delaware, you're going to find your way going through Belmar. It really is sort of the gateway into South Jersey.
But in recent years, this 70-year-old interchange between Interstate 76 and 295 had become a nightmare for modern traffic. And locals like Marie Hiley.
The problem seems that you have to do a lot of weaving to get over to 295 and slow down on the ramps to 35 miles an hour.
You hit this point where everything just merges together. It's sort of like, you know, in high school when the bell rings and just all the kids are just kind of like bouncing off each other trying to get to the next class.
By 2010, plans were underway for a massive upgrade. The goal, to reduce the volume of traffic meeting at a single point.
The state looked at more than 20 alternative options, including tunnels and bridges and various combinations of both.
In 2013, the authorities revealed their $1 billion answer. Elevate the lanes of I-295 above I-76 with a 1.6-kilometer bridgeway.
In the end, they settled on a system of ramps and bridges that would allow traffic to flow smoothly through the intersection.
Before the bridge section was built, work began on the approach ramps. The simplest way to support an approach ramp is to create a wide sloping embankment and build the road along the top. But at its eastern end, the approach ramp would have to fit between existing developments.
On one side is a very large cemetery, and there's a Belmar Park housing development, which was on the other side. So they had to sort of wedge things in between these two very large developments.
With no room for large embankments, engineers designed a narrow ramp held in place with retaining walls, sitting on a smaller embankment. There was one more complication. The existing interchange was critical to both residents and commerce, so it had to remain open during construction.
You already have hundreds of thousands of people a day traveling the roadways. There's no way that's going to be fast and easy and painless.
The momentous project unfolded over 8 years while traffic flowed all around it, until one wet weekday in 2021. March the 25th, the town of Belmar was recovering from a torrential rainstorm.
This area had seen unusually bad weather, with almost double its normal rainfall levels.
Despite the weather, work continued on the new ramp while commuters travelled through the intersection. Just before noon, the retaining wall of the new ramp failed catastrophically. Local journalist Mark Matthews arrived to witness the devastation.
But when I first saw the wall bulging out and the ground lifting up, it was just unbelievable. Just shocked.
The ramp was left on the edge of total collapse.
The wall had just sunk. It kind of went like a U and had sunk down, and portions of the wall were crumpled. It's very frightening.
The interchange below ground to a halt as authorities raced to assess the situation. Luckily, no workers were on site when the wall failed. Authorities were forced to close an entire lane of I-295 as they stabilized the damaged wall.
This was going to be key to one of the state's most vital intersections, and it was failing even before it was completed.
An official inquiry was launched to uncover the cause of the collapse. Residents and drivers wanted answers too.
How does something that is brand new, hasn't even had any traffic driven on it, just collapse?
Just seeing that collapse has made everybody fearful of the integrity of the whole project.
Although the investigation is ongoing, Professor of Civil and Environmental Engineering George Guar spotted a clue in the earthen embankment supporting the ramp.
You can see the big crack here, and also the earth embankment shifted to the left. So I believe the sequence is that earth embankment fell first, and then soil contained by the retaining wall fell in, because you're losing the support below the retaining wall.
The initial failure was caused by waterlogging. A shallow drainage channel at the foot of the embankment, called a swale, was specifically designed to allow water to collect and soak away. But here it looks like the recent storms may have tipped the balance in Mother Nature's favor.
I believe after the rainfall, a lot of water got into the swale. So if water level goes up in the swale, then it will raise up the groundwater table inside the earth embankment.
With the ditch full, the water couldn't drain properly from the material inside the new ramp, which made the whole structure vulnerable to movement.
The heightened groundwater table wasn't the only side effect. The water that accumulated in the ditch likely also caused erosion at the base of the saturated earth bank.
I believe that inflow have caused the erosion and scour at the toe of the earth embankment. I have a good reason to believe that led to the embankment failure.
The eroded embankment collapsed like a landslide, pulling the earth and the road with it.
I really hope that for future projects on our highways, that they would really study this project, the collapse of it, what happened.
Whatever the exact cause of the collapse, as the project moves forward, there's no doubt lessons will have been learned.
It's an unfortunate thing what happened, but it has the attention now, it has the engineers looking at it, and I really do expect we're going to end up with a roadway that is going to be stronger, safer, and it's really going to solve a lot of the local road problems that we're dealing with, both for commuters coming through the area and for the town of Belmar.